Hey, I want to show you how to use Excel to do your graphs for the Kinetics Lab. This is for Investigation 9. And you're going to be taking your absorbance and time data, and you're going to use Excel to calculate concentration from absorbance. Now, absorbance is the value you got from the spectrometer. The concentration is calculated from your Beer's law plot that you made in the pre-lab. And if you look, this is where Excel is really powerful. If you look in this cell C9, so when I refer to C, see this is column C, row 9. You'll see there's a formula and it says equals, so this is saying the number in C9 is going to equal A9 minus 0.07321, all of that in parentheses, divided by 52,500. So that is the equation, that is the y equals mx plus b equation that you got in the Beer's law plot rearranged to solve for concentration. So when you do that, so the first thing you need to do is enter your values for the slope, which is this number, and the intercept. Okay, and then you'll have your formula in there. Now, this is where Excel is incredibly powerful. You've got a whole bunch of data. Now, I've got a little bit of made up data right here that I am just going to cut and paste into here. Okay, now this is just made up data. All right, I just made it up. But here's the power of Excel. If I have my formula here, I don't have to enter it over and over. I just grab that little corner and I pull down, and look how the formula changed. A10, okay? A11, A12, A13. So it knows that if I wrote the formula here to use A9, when I copy it, it knows to then use the value in A10, A11, A12, A13. So now I have concentration and time data, and that's actually what I need for the zero order plot. And you see over here that these points have already been put into the zero order plot. And you can see all the other information here, y equals mx plus b, slope plus the intercept, and you can see an r squared value. Now, I'm just going to warn you right now, my fake data is going to give straight lines for everything. So just ignore that. I'm just basically showing you how to use Excel. Now, if you look, what's here in B9? Another formula, and it says take the log of C9. Well, what is C9? C9 is the concentration calculated from the absorbance, and we're going to take the log of it. And if we look here, we're taking the reciprocal of C9, or the inverse. Now I can take both of those and copy them down. All the calculations are done. Look, C10, C11, C12. See, it knows that. And look, all three graphs are done. Now, obviously, this is made up data, so it's not actual reaction data, and it's so we're seeing straight lines for everything. That is, of course, wrong. So do not write this in your lab report. Do not use this as fake data for your lab report because it is not legitimate kinetics data. But when you have your data and you can copy, we've made 40 cells here, or I guess it'll be 38 cells or something, that 31, that you can copy a whole bunch of your data down, and you could drag this all the way down and copy it down. So you don't have to enter, you don't have to calculate it. This is why Excel is so powerful. You can just enter the formula one time and then drag it down, and you could have 1,000 data points and calculate them all in 1 second. It's so cool. And the graphs, I would suggest that maybe if you have time, or you spend some time learning how to do graphs in Excel, because when you get to quantitative analysis, your junior year, you're going to have to be able to do this in Excel, and it's a really powerful tool in science. So I hope that helps.